Section 3.3, proofs with parallel lines. So now we're actually going to use, last section 3.2 we did the corresponding angles theorem. Now we're doing the corresponding angles converse. And the difference is that before, remember we talked about they had to be parallel. So in 3.2 it says if two parallel lines, then the angles are congruent. This is the converse. This is the backward order. This says then the lines are parallel. So it says if you have two lines and the transversal and the corresponding angles are congruent, maybe this angle and this angle are equal, let's call this line A and line B, then A is parallel to B. If the corresponding angles are congruent, then the lines are parallel, guaranteed. Similar idea here with the alternate interior angle converse. Then the lines are parallel. If you have two lines and a transversal, and the alternate interior angles are congruent, then line A is parallel to line B. The alternate exterior angle converse, then the lines are parallel. If you have two lines and a transversal, I'm going to call those lines A and B, and the alternate exterior angles are congruent, maybe those two right there, then A is parallel to B. The consecutive interior angles, if you have two lines cut by a transversal, and here I'm not marking them congruent because it doesn't say congruent, it says they are supplementary. Remember, consecutive interior angles, we didn't want them to be equal, we wanted them to add to 180. So if the measure of angle 1 plus the measure of angle 2 equals 180, then A is parallel to B. It is the converse you use if you are trying to show that they are parallel. Now the last one is the transitive property. So let's say we have three lines, A, B, and C. And we know that A is parallel to B, and B is parallel to C. So these two will never cross, and these two will never cross. Well then, A is parallel to C. And we can actually use the converses here and the theorems to prove this sort of situation. I don't plan on doing the proof. I might do it at the end of this lesson depending on time, but you can remove the overlapping part with parallel using the transitive property of parallel lines. So example 1. Find the value of x that makes m parallel to n and explain your reasoning. So if we want m to be parallel to n, then we need these angles here to be congruent. We want them to be equal. So you set them equal. 8x plus 55 equals 95. And you solve. Subtract 55 from both sides. 8x equals 40. Divide both sides by 8. X equals 5. Now the reasoning for this is that when x equals 5, these two angles here are equal. That is, they are congruent. And what's the vocab word for these two angles? This one is interior, this one is exterior. They're both kind of on the bottom right side. That is, they are corresponding. So our reason is the corresponding angle converse. Just like we use the abbreviation CA, AIA, AEA, CIA in section 3.2, we can use them in 3.3 also. Notice though, this is the converse because we aren't told that they are parallel. We are trying to make them parallel. That's the converse. Let's look at V. What are these angles? What's the vocab word? So here's the inside. So they're both exterior, and this is below the transversal. This one's above the transversal. So we're going to use the alternate exterior angle converse. And the alternate exterior angle converse says if these are equal, then the lines are parallel. So set them equal. 200 minus 2x equals 130. Subtract 200 from both sides. We're trying to get the x by itself. So negative 2x equals negative 70. Divide both sides by negative 2. X equals 35. Now on the back, example 2. These are some of my favorite problems. So decide whether there is enough information to prove that M is parallel to N, and if so, state the theorem you would use. So remember, these theorems show that the lines are parallel. These show that the lines are parallel. Let's look. What do we have here? We have two angles marked congruent. Are they corresponding, alternate interior, alternate exterior, or consecutive interior? So here's the interior. So it looks like this one is interior and this one is exterior. But notice they're both kind of on the bottom right. So these are corresponding angles and they are congruent. Well, according to the corresponding angles converse, when corresponding angles are congruent, then the lines are parallel. So, is there enough information? Yes, by the corresponding angle converse. All right, what about B? What are these angles? Here's the interior. So we have one interior angle and we have one exterior angle. All right, that's okay if they are if they are corresponding. You might have one inside and one outside, just like we did here. But what are these angles? They're not corresponding because this one's in the top right and this one's in the bottom left. But if you look at it, right here, we have an X. And they are on opposite parts of the X. These are vertical angles. Were vertical angles one of our rules, one of our converses? It was not. So here, there is not enough information. And the question is why? Well, if you think back to chapter 1 and used again in chapter 2, what do you know about vertical angles? They are always congruent. In fact, if I covered up this other line, does it change the picture? No. These two angles are still congruent. We don't even need line in order to show or to know that those two angles are congruent. Vertical angles are always congruent. They don't care, vertical angles don't care if your lines are parallel or not parallel, they are always congruent. Now the constructing parallel lines, we are not constructing parallel lines because I can't guarantee that everyone has a compass at home. I'm not even sure that I have a compass at home, to be honest. So we're not constructing. We are, however, going to do a proof. So on a separate piece of paper, or you might even have room down at the bottom of your paper if you'd like to write it down, I'd like you to take just a moment, pause the video, and write this proof down. All right, so we are given that A is parallel to B and angle 2 is congruent to angle 3. We are going to try to prove that C is parallel to D. And then we have line A and line B, line C and line D, and then we have some angles 1, 2, 3, and 4 labeled to help make the proof a little bit easier, just using the numbered angles. And let's do a 2-column proof. Statement on the left, reason on the right. Line 1. All right, what always goes on line 1? Line 1 is always a given. So I'm going to put the first given here. A is parallel to B. That's given. Now, depending on who's making the proof, your book oftentimes puts both givens on the same line. That's okay. You could make kind of like 2 lines for line 1 and put both givens. You could put a comma and then put the second given. Both are okay. I personally like to put them on separate lines and say on the final exam they will be on separate lines if you have a 2-column proof. So, second line. A is parallel to B. What does that mean? We know A and B are parallel. We're told that. So here we have 2 lines and a transversal, or here we have 2 lines and a transversal. Right? We can use angle 2 and angle 4, or we can use angle 1 and angle 3. Now, look at our next given. Our next given has a 2 and a 3. So my thought is maybe we use angle 1 and 3, and maybe we'll have some sort of connection going on here, some transitive property, that maybe we don't need the 4. I don't see a 4 up here at all. So let's see here. A and B are parallel. C is a transversal. What do we have in that picture right there? We have some alternate interior angles. And what do we know about alternate interior angles when the lines are parallel? Well, because A is parallel to B already, we know that because it's told to us. We're going to use the theorems because they are parallel. A and B are parallel already. The alternate interior angles are congruent. Angle 1 is congruent to angle 3 by the alternate interior angle theorem. We're using the theorem because we know A and B are parallel. Let's put our other given down. Angle 2 is congruent to angle 3 because that's given. Now look at line 2 and look at line 3. Do you notice anything? Angle 1 is congruent to angle 3 and angle 2 is congruent to angle 3. Notice both are congruent to angle 3. And if both angle 1 and angle 2 are congruent to angle 3, that means that angle 1 is congruent to angle 2. And what was the name of the property that allows us to eliminate that middle piece? That's the transitive property. Now, technically, if you said substitution, you're not wrong. You could also put substitution as your answer here. All right, we know 1 and 2 are congruent. So now we know that angle 1 and angle 2 are congruent. How does that help us? Well, now you need to focus on a different part of the paper. Look at that. What do we have there? We have 2 lines with a transversal, and we know that the bottom left angle here and the bottom left angle here are the same. Bottom left, those are corresponding angles that are equal. And if the corresponding angles are congruent, then that means line C is parallel to line D by the corresponding angle converse. So we used both the theorem and a converse in this proof. We used the theorem when we knew that the lines were parallel, and we used the converse to show that they were parallel. That's a really important distinction, theorem and converse, and this is why in this section it is really important to write down the word theorem and write down the word converse. All right, because we're doing okay on time, let's do that proof. The proof for the transitive property of parallel lines. It's a nice little proof, works very nicely. So here's the proof. Pause the video and go ahead and write it down. All right, so let's do a 2-column proof. Statement and reason. Line 1, always the first given. A is parallel to B. And how do we know? It's given. All right, we know that they are parallel. We know they are parallel, so that means that we're going to use one of the theorems. Now I went ahead and labeled 1, 2, and 3. This is one of the most direct routes in this proof. If we know that A and B are parallel, then the corresponding angle theorem says that corresponding angles are congruent, that angle 1 is congruent to angle 2. You don't have to do this with corresponding. You could do it with alternate interior and so forth. I think corresponding may be the fastest, easiest for me to see. So wouldn't be any fewer steps. All right, we knew they were parallel, so we used one of the theorems. Let's put the other given. B is parallel to C, given. Because we know B and C are parallel, we're going to use one of the theorems. Look, angle 2 and angle 3 are corresponding, so that means angle 2 is congruent to angle 3. The corresponding angle theorem. Now, we somehow need to end up that A and C are parallel. And because we're trying to prove they're parallel, we're going to use a converse at the end. But we need to make that connection first. So look at line 2 and look at line 4. Angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. We can use the transitive property or substitution again and remove the part that doubles, which means angle 1 is congruent to angle 3. And if we know that angle 1 and angle 3 are congruent, look at where angle 1 is. It's on line A, and angle 3 is on line C. And they're both kind of like on the top left. Those are corresponding angles. And the corresponding angle converse says, since angle 1 and angle 3 are corresponding and they are congruent, then A must be parallel to C. At this point in time, you should have enough information to do your homework.